All right. Well, looks like we got a really small group for our little talk on VDetect. Maybe I lost my audio. Can you hear me? Audio working? There we go. All right. Looks like we got a pretty small group. Maybe we'll have some more people trickle in as we get going here. So product we want to talk about is VDetect, which is an open source AI platform for primarily cybersecurity use cases, but also just any data management problem, data integration use case. But before we jump into technology, I figure we talk a little bit about what we're seeing in the market right now, why 10x National Security even launched, and sort of some of the challenges and opportunities here. So Brian Knobs, CTO here. I'm John Eubank, founder and CEO. And what we've both experienced over being in this market a lot is people taking free and open source software and turning around and turning it into a license. So part of starting 10x was this firm belief that free and open source needs to remain free and open source. All too many companies are really price gouging the DoD, taking advantage of the DoD with open source under the hood and some very small, insignificant customizations that they suddenly start charging licenses for. So everything we're going to share today, it's available without license. There's no proprietary data rights associated to it. You can download it, you can modify it, you can customize it as you see fit. And at the end, we want to do a little bit of a Q&A, have a little bit of discussion. We've got some coffee to give away here at the end. So in addition to free and open source, we also just saw a gap in the community for companies that would take on really hard problems in the software engineering space that weren't trying to lock the government into some proprietary baseline. We believe the government needs software teams that stand up to build working software that doesn't come with long-term legacy lock-ins. All too often, especially in the large defense prime space, they try to lock you in. You're stuck. Once you've started using their software, you can't get off of it. You can't adapt. You can't evolve. I think we've all seen it in the space. So core to what we want to do is to keep out of that space. So Brian, I wanted to get a little bit of your thoughts on just those challenges, why we're doing this at 10x, and then we'll jump into the actual technology.
Yeah, absolutely. And I'm going to go ahead and play this video in the background, but this is really just examples going on just for us to talk to. They're demonstrations of software that we built. You're welcome to come by the booth and we can give you live demonstrations if you'd like. But to get back to what John was talking about, it's what 10x is really building out is this concept of rapid production. We want to be able to take the newest technologies that are coming out in the open source area, being developed by large companies that are still open source, and be able to get them to the mission as quickly as possible. And open source shouldn't be like a paywall, right? Like it shouldn't be something that locks you in, like John's saying. So this is an example of one of those things. It's a secure collaboration platform that we built out. And then this is another one of VDetect. This is an AI platform. But this is a perfect example, right? This is the underlying platform here is called Morpheus. It's built by NVIDIA. It is completely free and open source. And you're able to use this as a base to build up the integration, right? And I think this is where a lot of products that are being built are really built around this concept of like, okay, it's a solution that fixes all your problems. Then you get in, it's like, well, no, it has to be trained for your environment. It's like, yes, that's how machine learning works. And what Morpheus gives you is that underlying platform of how you train it. So for VDetect, this is an example framework for how you can take Morpheus and apply it to do things like abnormal behavior detection. So just to explain really quick what's going on the screen, we quickly developed a demonstration environment where we were able to spin up a bunch of virtual machines. We were able to drive those using large language models to create a very realistic life cycle of traffic on a network with different personas. And then within those personas, we started generating offensive traffic or indicators of offensive traffic that wouldn't be caught by necessarily a antivirus or some other intrusion detection system, but is able to be caught by things like abnormal behavior detection. So this is where we're using machine learning. We're training up the underlying infrastructure to understand what that environment's supposed to look like. And then when things happen that are abnormal, we get to alert that and bubble that up to the top, right?
Yeah, and just hitting on this one in particular with Morpheus, you can go out and Google it. Booz Allen, 6, 7 other large multi-billion-dollar companies have built licensed products on top of this. And this is just one of the themes of 10x where we just have a fundamental problem with how large defense contractors are operating in this space. is Booz Allen is out. You don't even know it's Morpheus under the hood. It's Booz Allen AI for cybersecurity. It's only one press release that they did with NVIDIA and Booz Allen together where they talk about using Morpheus. That's the only way you would know they took free and open source and put a multi-million-dollar license on top of it. So from us, you can get the exact same capability that 7 different large defense contractors are offering right now, all of it without a license, does all the same features, maybe even outperforms them because some of their license stuff they've added in is not all that functional. And it's truly what open source should be, is it stays open source. It doesn't turn into some licensed product.
That's absolutely right. And I think it gets to what 10x really we see ourselves as a systems integrator, a software integrator, right? We bring us a problem, we're going to go out, we're going to find the solutions that can get you to a functional system as quickly as possible. Do any software integration that needs to work or happen to make that happen, and then give you the platform, let it run, right? Like we want to help just rapidly create these production solutions.
Yeah, and then, what is the genesis of this? Why are we here? So most people in the community know me for this thing called Big Data Platform, or in the Army, Gabriel Nimbus. I was one of the original founders of that program, sold that company in 2021 and moved on to other things. And we really see this need for a way to adopt new and modern technologies and get them into operations faster. And I guess one of my big learnings out of that platform was we really became this amazing data platform, but it locked people into a lot of legacy technologies. It was really hard to work with, really hard to maintain, really hard to build and deploy new features on top of it. And there's a lot of modern technologies that are out there in the space that can solve a lot of the same platform problems that don't come with all that legacy historical challenge of doing massive scale data platforms 10 years ago came with. And so this is one, we can even deploy this onto the BDPs, or I know they're being rebranded like the JCRS -Ds and Es and Os. This can deploy on top of those environments. It's all containerized and can run on them, but it also provides a lot of the features of a platform like that in a much more intuitive and easy to use form factor.
Absolutely. And I feel like because we got such a small audience, let's just make this about you guys. Like, what do you want to hear about? Because John's got this experience on big data platform, but also doing just decades of creating solutions around handling extremely large amounts of data. My background is offensive cyber, built up companies doing full CNO, OCO actions, a lot of exploit development, but also large software system solutions. And most recently with 10x, we've become experts on the use of machine learning, AI, LLMs, everything else. So what questions you got? Hit me. Yeah, come on. I know you got a question. You do.
Everybody that asks a question gets coffee too. So we got a whole bean and already ground coffee, and we got lots more bags in our booth. So.
She's like, I was just looking for a place to sit.
No. So I was wondering a lot about like the MDO and the AI and ML, but in terms of software-defined networking and knowing if you knew anything about that. That's what I had came to
I know a ton about software-defined networking.
That's actually what I wanted to know more. Just really just pulling in as much as you like.
So what problems are you having with software-defined networking that you're looking to solve with
defining it?
You're defining it.
Yeah. Okay, so when people ask me what it is, I know that OSPF is not the right answer. That's what people, like a misconception a lot of people have about it. And I was trying to find ways that I could explain it to more people, and I'm trying to write capabilities for it as well inside of our hardware. But that was it.
No, it's interesting. It's an interesting platform that we haven't gotten into too much with 10x so far. But the concept of software-defined networking, right, is that you're able to not have to implement hardware abstractions to be able to isolate different networks. And really the core of what you're trying to get at is like a zero trust kind of infrastructure, right? And being able to dynamically build out separate enclaves and control that all using software, right? So this is a perfect situation where you can start to use things like machine learning to define out what your system should look like, but then also start to feed all of that data, right? So as you're going to be doing metrics and logging on all those different network segments, you want to be able to make sure that people aren't taking advantage of that software-defined networking, hopping across different networks. So that's where using ML to do things like abnormal behavior detection is actually a really good fit for that, because you're able to say this traffic shouldn't exist on this network, right? So looking at the defensive side of that, and then, yeah, we could go on for days on software-defined networking. But
and
at
I
the same
think the
time, we only
ability
got 10 minutes.
to feed into one of these platforms and then take action. You can
Yeah.
redefine the network to lock the adversary out in real time. Sort of that SOAR orchestration kind of aspect that comes out of a platform like Morpheus. Yeah.
Yep. And then from the open source side, there's a ton of open source platforms that are specifically designed around doing that. You've got open source routers like Viata and other things that you can deploy on hardware that implement that at the lower hardware level.
Yeah. Any other questions in the room?
So just curious if you can maybe give me another example of like, I can easily see anomaly-based detection being a very good fit for ML because you feed data in and it takes all the data and decides, hey, this doesn't look like the rest of the data. Mm-hmm. But can you maybe give another example of like an ideal solution?
Machine learning solution?
Yeah, an ideal situation or solution where you would implement this just so that some of us have an idea of like, where else could this benefit us?
Yeah. It's a great question. And I think that it's one of the things where when people talk about AI, especially these days, you don't actually know what they mean, right? AI has become a buzzword. Agentic AI has become even more of a buzzword, right? So when you're talking machine learning in general, and especially in like this instance, we're talking abnormal behavior detection. Well, how do we actually do that? We're doing this using an autoencoder. So that means that we're taking data, we have an encoder to go into a specific format, and then we see how wrong it is, right? And that's one style of doing machine learning, but there's literally thousands of different styles. So a big part of it is being able to keep up with those different methodologies of what does machine learning actually mean. So another really good example of how we do this is something for unstructured to structured data, right? So for example, PDF ingestion. You can define out, here's the fields that I want, and then you're able to have machine learning train up on what PDF looks like and what those fields should look like, and it will extract those fields into a structured format like JSON. Like that is a perfect scenario for machine learning.
Yeah, I think a couple other examples are, so we have this platform running on Redhound, which is one of the contenders for the Joint Cyber Hunt Kit right now. Hopefully it'll get rolled out to the Army here on the DDSM platform in the future here. But that network behavior, profiling a network, baselining a network, which, talking about software-defined networks, your networks are living, breathing things. Yet everybody's like, oh, I need a baseline. I need to know what's good. I need like, and it's like, well, every time I log in, the network's different. Every time I tap it, every time I touch it, it's the software-defined networking is making it different. So where does a platform like this come in handy? That baselining, like, what is the network look like at this point in time? How is it behaving? What's normal? What's not normal? And then how fast can you get that? So,
Right.
depending upon the size of the network, there's a lot of variables there. But I need to get to known behavior as fast as possible. So, a tool like this, maybe on a smaller network, we're talking like 5 minutes, I can start understanding this is the normal behaviors I should be expecting on this network based upon the device profiles, and then start looking at, okay, what's behaving abnormally in this environment? That's like a really good use case right out of the gate. And then hopefully you got some asset lists or something. You can say, hey, this thing's supposed to be a printer, but it's behaving like a file server. But the machine learning is just telling you that in real time. You're feeding, that's where the LLMs and all come in handy, is you're feeding that asset list in, and it's auto-identifying for whoever the operator is, hey, this printer is actually hosting files and shouldn't be hosting files on it.
No, it's a really good point. And it's a really good point to bring up that these things can't be static. They need to continuously train to continuously improve and adapt to the current situations. I think where things start to become look like magic is when you have large language models, because they've gotten so good to the point where it feels like you're talking to a person, but there is no thinking, there's no, any cognitive at all, right? So where large language models are extremely good is being a human machine interface, right? But you don't want it to do logic for you because it's going to hallucinate an answer. It's going to tell you what it thinks it should know, and that is not the right way to use it. But using it as a way to interact with the machine or with tools underneath that do know how to talk to the data, now you start to create a cohesive system that can just accelerate your workforce, right?
All right.
What other questions we got?
Yeah.
I saw him pull his ear, but that means it's a question. Oh, he's got one.
VDetect. Here, I'll get you a flyer. Give me 1 second.
Harry's got a question. Go for it.
So here, what I'm looking at on the screen is all of these open source. That's question number one. Question number two: how long did it take to come up with this or actually develop these or get these working on a real world network? And question 3, does open source like this have to be ATO certified?
Yes. Fantastic questions. So the things that aren't open source in this are things that don't actually matter. So like the Elasticsearch, or I guess Elasticsearch is open source still for now.
Depends on the day.
Yeah, yeah, for today. As far as everything else is open source. So we have developed a framework underneath that helps glue a bunch of this together, but we're making that open source as well, right? And that gets into the not just a keep open source free, but it's also if we're going to benefit off it, the community should benefit off of it too. So that's one part of it. As far as deploying it goes, the nice thing about relying on containerization is that you can deploy this at scale very, very easily and very, very quickly. Now, where it gets complicated is feeding the amount of data into it and understanding how long it's going to create that baseline for that specific environment. That's going to have to depend on each environment.
Yeah, and that's part of the whole ATO thing is as we move to a lot of containerized architectures and whatnot, it's where we can deploy to JCRS D, E, or O, depending which environment you want to run it in. But then we're going to take the accreditation package that comes from that platform, and we're just going to be an additional container capability running on it. So we can deploy sort of tomorrow to those kind of environments. If you want to rip and replace, since we have all the capabilities, we don't really need that accredited platform, then you would have to go through your full ATO lifecycle to obtain an ATO for it. But we've already baked that into how we build these platforms and architectures. So we've got our software factory internally set up, meets all the DoD requirements on the software factory requirements, so that we can come in and get those ATOs very quickly.
Yeah, exactly.
With hardened containers already built, all that.
All right, we're wrapping up here at the end. Thank you for coming to my TED Talk. Is there any last minute questions? All right. Well, our booth is literally 2 steps that way. Feel free to come by and ask us about all the other stuff. We've showed off a collaboration platform. Honestly, we built this because we wanted it and it didn't exist. We needed to be able to run secure collaboration in isolated networks and be able to do real-time voice, video, and everything else. So we built that. This VDetect, this is really get the complete opposite end of the spectrum, doing large data center machine learning. We've got everything in between, as far even down to fully embedded on-person localized LLMs and everything else.
Yeah, so in closing, we got some flyers up on the table for everybody that asks questions. Come by our booth. We have either a whole bean or already ground coffee. You can grab a bag from our booth there. And then, at our table right around the corner, we're happy to take additional questions or do deeper demos. Thank you all for your time.
Thank you.